Fifth graders, welcome to lesson 6-4, dividing decimals by two-digit whole numbers. In the heart of the mysterious Mathopolis, an ancient city where numbers rule, an ominous challenge was set forth, called the Decimal Dilemma. A treasure of unparalleled mathematical power was said to be hidden deep within this math city. The problem is it's guarded by Decimus, a guardian of decimal secrets. A group of daring adventurers led by the fearless mathlete Max set out to conquer the decimal dilemma. Max was accompanied by his brilliant friends, Decimal Dana, Tactical Theo, and Precise Petra. Their quest was to reach the treasure before the rival Math Mavericks, a cunning group known for their exceptional math skills. As the adventurers entered the math city, the air crackled with anticipation. The Decimus materialized before them, presenting the first challenge. Decimus said, "Brave mathematicians, to proceed, you must divide 156 and 8/10 divided by 8. Max confidently responded, "Let's tackle this together. First, let's think of this problem without the decimal." So remember our does McDonald's sell burgers? The first thing we want to do is divide. How many times does 8 go into 15? Well, it can't be 2 because if it was 2, 8 times 2 is 16. It's got to be 1. 8 times 1 is 1. 15 minus 8 is 7. So we did our division, our multiplication step, which was 8 times 1, and our subtraction step, which is 15 minus 8. Then the B, bring down. We want to bring down the 6. Now we start over with division. How many times does 8 go into 76? So for that one, we can do guess and check. 8 times 10, I know, is 80. So let's try 9 times 8, which would be 72. So 8 times 9 is 72. Next is to subtract and bring down. Bring down our next digit of the 8. All right, I know 8 times 5 is 40, and I know 8 times 6 is 48. So that works. 6 goes up here. We're going to subtract our 48, and we get 0. Now, there was no decimal here, but is the decimal going to change our quotient or answer to our division problem? No, not as far as the digits go. So we can copy those digits over here. Now the question becomes, where does that decimal go? Well, there's two strategies we can use. The first strategy is to take the decimal and count how many spots it takes to get to the end of the number. So in this case, how many spots does it take to get to the end of the number? Right, 1. So because it took 1 spot to get to the end, we're going to put the decimal 1 spot back inside the number. Okay, now I'm going to rewind all of that, and I'm going to show you the second option, which is the option I like. I picture this division house here as a big mansion, and this mansion is so cool that it actually has an elevator, and the decimal can actually go inside the elevator, and the elevator actually goes to the rooftop. So that decimal point is going to go directly above wherever it starts inside the division problem. So you get to choose whichever method that you prefer. We're going to do one more practice problem. Now, the gate to the next level creaks open and the team advances. They are now in the labyrinth of decimals. The adventurers faced a crazy amount of doors, each marked with a decimal division problem. Dana was examining the doors when she said, "Here, I found it. Our next challenge is 428 and 16 hundredths. Divide it by 12. So remember, if you want to move the decimal over, how many jumps, how many egg cartons would we have to make to get this decimal point to the end of the problem? Right, 2. 1, 2. So we know in our answer, we're going to move the decimal point 2 spots back, or we can put the decimal in the elevator, play some elevator music, and take it right to the top. Now we can treat this as a normal long division problem. Okay, 12 goes into 42. I'll do my guess and check. I think 4 is going to be too much, so let's try 3. We get 36. Okay, there's my division, and my multiplication is 12 times 3, which is 36, then my subtraction, and then my bring down. 12 goes into 68. Let's try 5. And I get 60. So 5 goes here. I'm going to subtract the 60. I'm going to bring down the 1. 12 times 7. Oh, that doesn't work. It's bigger than 81. But I'm going to keep that there. I'm not going to erase that because that might help me later on. 6 times 2 is 12. 6, 7, 72. So I put my 6 here. We're going to subtract 72. I get 9. I bring down the next digit. 96. Well, if I look here, that's exactly why we don't want to erase that. We can put the 7 up here, and we're going to take that 96 and subtract 84, which was the answer over here. Oh, I just realized something. We have 12 here. So if we have 12 here, we probably shouldn't have 12 here. So we need to add another 12. So instead of 7 up there, we want to multiply it by what? By 8. Let Mr. Pietzak know after this video if you caught that mistake before him. And that's going to leave us with 0. And our final answer is 35 and 68 hundredths. Did you get it? As the adventurers entered the treasure chamber, the Math Mavericks arrived, panting and defeated. Max's team had prevailed. Decimus said, "Congratulations, brave mathematicians. You have unlocked the decimal dilemma and proven your mastery of dividing decimals by 2-digit numbers." Max proudly claimed, "We did it as a team." The treasure of radiant crystal levitated before them, pulsating with mathematical energy. The Math City erupted in cheers as Max's team emerged victorious, their hearts filled with the thrill of mathematical conquest. And so the legend of the decimal dilemma spread throughout Mathopolis, inspiring future mathematicians to embark on daring adventures and conquer the challenges that lay hidden within the world of decimals.